Hey guys, I'm going to be showing you how to do some troubleshooting on one of the polymer tub dishwashers. This is one of our top control dishwashers. If we have an unresponsive unit that's not working for the customer, we're going to go through some checks that you can perform to try to determine what the issue is for the consumer. So we're going to start by removing the door skin. This is going to require a Phillips head screwdriver. Now be very careful when you're taking these two screws out right here in the front that actually are hidden underneath the handle, just so we don't scar anything. We don't want to scratch or mess up the front. Keep it nice and pretty for our consumer. Alright, now we're going to open our door. There are 4 Phillips head screws towards there's 2 over here, 2 over there, towards the bottom section of the door. Don't worry about any of these torque screws up here in the top. Those are actually holding our console in place. Alright, now that I've got all my screws out, this is where it gets a little tricky. You're going to hold your door skin by the handle as you lift the door back up, and we're going to gently lower it and pull it off. Alright, so I wanted to point out the most useful tool for repairing this dishwasher is actually hidden right here behind that door panel. That's our tech sheet. That's going to tell us a lot of the different values that we should get off of components, should tell us kind of voltages we should expect, and it's going to give us our overall wiring. To continue with our non-responsive unit though, let's go ahead and take our kick plate off so we can get to where our incoming power supply is. Alright, so to gain access to our junction box, we got 1/4 inch screw. Now I do have the power supply at the breaker box already cut off. We're going to grab our meter and we're going to do some voltage checks on our incoming power. Alright, so now that we've finished with our checks down here, let's go ahead and put our cover back on. Alright, so we verified our voltage down at our junction box. We have proper voltage, proper polarity, a good ground. The next step, or the next thing that I would check, because the voltage goes from the junction box up to the door switch assembly or the door latch assembly. So that's where we're headed to right now. Now there's 6 torque screws here that are actually securing the control panel in place. Now this last screw, whenever you're pulling out this last screw for the control panel, make certain you're holding your control panel. That way it doesn't just fall off and yank on the wires or mess something up. We don't want to create any shorts, so we're going to gently lift it up and pull the control panel off. And as you can see, we got access to our door latch assembly now. Alright, so to check this door latch assembly, I've gone ahead and I've restored power to the unit. So we're going to be looking for that 120 volts. Now what you need to know to check the door latch assembly is it's got 4 wires. You have 2 blacks on the right, 2 whites on the left. Now the ones closest to the door are coming straight off the junction box. These 2 right here in the front are the voltage that's actually going through the door latch and coming back to go to your control board. So we should always have, as long as we have power to the unit, on the 2 back terminals, the black and white, should have 120. In this case it's 119.5, which is good. With the door closed, these 2 front ones should have 120, 119.5. And the only thing that's going to stop that voltage from going to these 2 front terminals, these 2 front wires, is if the door gets opened, it's going to lose that, it's going to break that. Another check you can do on the door latch, it's a visual test. If you actually pull, now keep in mind you need to support the control board whenever you pull these off, but just visually look at the terminals on the connector and look up inside of your connector, look at the spades that are on the door lock assembly, see if you see any discoloration on those terminals at all. You'd be surprised how many calls I have actually helped the tech figure out why the unit was not running, and it came back to this door latch. Now the door latch was allowing the voltage through at that specific point in time, but the discoloration on the terminals is actually letting you know that there is a connectivity problem somewhere in this door latch assembly. So even though it's working at that point in time, it may not be working later on for the consumer halfway through a cycle. So always pull that off and do your visual checks on it as well. Alright, so we've got voltage all the way up to our door latch assembly. The next stop for our incoming power supply is going to be going to the main control board. So to test it, we need to remove the main control board cover here. There's 2 Phillips head screws. And we're going to slide this cover out of this little clip at the top, and we're going to lift it. We're going to slide our wires out and get it out of our way. There's our main power board. Alright, so now that we've got access to our main control board, the wires we're going to focus on are these 2 big ones over here, the red and the black. That's the P3 and the P6 connector. We're going to check there to see if we've got our 120 volts. Now you can remove these if you feel more comfortable. Just make sure you remove the power while you're doing it. I'm actually hitting the bare metal, the terminal on the board, and I am reading 120.5. So we've got our 120 volts going all the way to the main control board on this unit. All right, so let's go back over everything that we've basically discovered so far. So I've got my proper incoming voltage, proper polarity, and a good ground at my junction box. I've got proper voltage at my door switch. The door switch is showing closed. I do get it. My 120 is coming through because I had it on the back black and white and I had it on the front black and white when the door was closed. I didn't see any discoloration on the terminals or on the wires going to the door switch. And we verified we have proper incoming voltage at our main control board. Now if I had a completely non-responsive unit, if I open the door and my control does not light up, at this point I would order a main control board. Luckily, my control board is working. I was just walking you through these tests. Now I'm going to go ahead and show you how to start doing the troubleshooting using diagnostics. I'm going to put this back together and we'll do a keypad dance and let you see how to do some of the different tests on this unit for further checks that you may need. Alright, so there's two different diagnostic tests that we can run on this unit. One of them is they call it the relay test. It's a step-by-step test where you can activate each individual component to verify operation as you go through them. And the other one is a self-test where the unit actually goes through all those components for you. It runs each one for a set amount of time. We're going to do the relay test first, but to do any diagnostic test, to enter either of them, you actually have to put this unit in a power fail state. Now there's two ways to put this unit into a power fail state as well. You can go to the breaker, kick it off for about 30 seconds, but you need to be right back here with this unit whenever that breaker kicks back on or whenever the unit power's returned back to the unit, because whenever this display lights up, all the LEDs are going to light up. It's going to show a 188 in the display. That's when you have to do the dance to get it into diagnostics, is while you're in that power fail. That is actually what the power fail state looks like, is when everything's illuminated. But I'm going to show you how to do the relay test, how to enter relay test first. Alright, I'm going to go ahead and put my door skin back on. I just wanted to show you guys a little tidbit that I came across while I was doing this. If you notice, the top of this panel has a little bit of play to it. Now don't get too carried away whenever you're doing this. I don't want you to bend or create a seam somewhere on it. But it does have a little bit of give until it actually locks onto the tabs here on the control panel. So whenever we're going to slide this thing back up on here, we're going to get it right here. We're actually going to bend that a tiny bit, not bend it, but you know what I mean, just add a little bit of pressure, tweak it, twist it as we're putting it up on there, and it's going to allow the top of the panel to get over this where the locking mechanism area is, and it will fit snugly up on there, and then we can put our screws in. I'm going to be putting this unit into a power fail state using the keypad here. I'm going to go ahead and show you how to do that. Alright, so we're going to hold normal wash and wash temperature. We're going to hold those two buttons at the same time. We're waiting for all the LEDs to light up and the 188 to appear on the display. There we go. Now all we have to do is hit wash, or normal wash and rinse only. We just tap them. And right there, we're in relay test. That's what the RT stands for. Alright, so to run our drain pump, we're going to hit the top rack. It's going to give us a DP for drain pump. We're going to close our door and listen for our drain pump to run. We're good. Drain pump's running. Alright, we're going to use the Power Plus to fill the unit. This is going to energize our water valve. We just need to close the door to activate it. We're going to let it fill up for just a few minutes, just to make certain we have some water to push around when the wash motor's running for its test. I just wanted to point out too, while I'm showing you how to do each of these tests, you can cycle on off to any of these tests. Like right now I'm back to my relay test main screen just by hitting my Power Plus, back to my fill. Relay test screen. You can actually go through any of them that way. You can do your drain pump, same thing. The only one you cannot do that with is our wash motor. That one's actually a variable speed wash motor, so it runs at different speeds as it's, depending on how many times we press the button, we're going to hit the quick wash. It's going to give us a 0. This is the first stage, or the slowest speed for the wash motor. Let's close our door to activate it. Alright, so as you can see, it's bouncing between 2700 and 2800 RPMs. That's the speed that it is actually sensing the motor is running at. Alright, so then we're going to open up our door. We're going to hit our quick wash button again. Still going to show us 0 at the moment, but we should be able to achieve a higher speed. Let's go to our next one. We're going to hit the quick wash button again. It's still going to show us a 0. Close our door back. 3,100 RPMs. We're going to hit the quick wash one last time. We're going to shut our door. Topping out at about 3,400 RPMs. So these different speeds, these variable speeds, are what come into play when we're talking about our wash pressure. This is the different speeds whenever you're trying to explain to a customer the difference between scour, surge, and spray. Now you'll be able to help them understand why this is actually pretty cool technology. This thing washes with different water pressures because our motor is running at different speeds to push the water harder or softer. Alright, so let's check our soap dispenser. Now my dispenser's already closed. Make sure you close yours if it's not closed. We're going to hit normal wash. We're getting SD for soap dispenser. Let's close our door and give it just a few seconds. Well, probably about 30 seconds before it opens up. There we go. Alright, so I did want to point out too, something I found. I always thought you had to press and hold these buttons whenever you were trying to get into the relay test, or for that matter, the service test, the water service test. Once you get this thing in the power fail state to where it's lit up here, all you have to do is hit the buttons just a half second. Right now I'm back in power fail. If I hit them another half second, boom, right back into relay test. But I'm going to put it in power fail so that we can go back to our water service test mode. Alright, so I've gone through the relay test, but quite honestly, I'm more in favor of the water service test mode just because I can test everything quickly. I use an amp meter with an amp clamp on it. I actually put it on my incoming voltage wire, I put it into the water service test mode, and I just let the thing run through and I watch my meter and see what kind of amperage I'm getting off of each component. After you do it a few times, you'll start to remember what that amperage is for each component, and you'll know whether or not you see an issue. And I'm going to walk you through how I do one. Alright, so as you can see, my display is actually gone, my unit has gone back to sleep. I had it in a power fail state, but I didn't push any buttons. Now you can put it right back into power fail state from a sleep mode. All you do is hold your buttons, normal wash and wash temperature. Just press and hold them until your 188 pops up. Now to put it into water service test mode, we're going to hold the start cancel and the dry button, but we're just going to hold them for like a second or two. And then let go. 0 lets me know that we got on there. So let's go ahead and close our door, get down to our amp clamp and verify what's going on as this thing runs through. You can see we're probably just under there goes my detergent drawer. But we're right about 0.1, which is average for a water valve. A lot of times I'll actually have a temperature probe drop down inside of the unit at this point, just so I can verify the temperature of the incoming water. Comes in handy to know what the temperature coming in is, especially if they're having cleaning issues. Alright, so our wash motor kicked in. As you can see, it jumped up to 8.5 amps. That tells you the heater is also on right now. That motor does not pull 8 amps. The only thing that's going to pull that high in amperage is our heater itself. So we know our heater's working, and we know our wash motor's working because we can hear it actually moving the water around inside. Right now it is running that motor at 3,400 RPMs. It's going to have a brief pause and it'll drop down to 2,800 RPMs. There goes our pause, and you see a little bit less amperage pulling out of it now. Should be running at 2,800 RPMs. Still has the heater energized, still pulling that high amperage. Everything else on this unit pulls less than 1 amp, to my knowledge. One other thing while this thing's washing, I'd like to point out, if you check your display, keep monitoring your display as it runs through these tests, it's going to be checking different components as well. It's going to be checking the fan damper, the turbidity sensor, the thermistor. If it senses an error with each of those components during this testing, it's going to throw it up on the display and let you know, hey, there was a problem. As long as there's not a problem, it's just going to keep illustrating or keep displaying the test that you're actually on. Right now we've made it to test 6. Next one should be our drain, that's test 7. Drain pump generally pulls about 0.6. There's our drain pump right there. I found if you ever have the wash pump running without the heater, generally the wash motor itself pulls about 0.7, somewhere close to it, more than acceptable. And we're back to heating. We're back up to, that is just the heater running this time, 7.2 amps. Like I said, the heater's the only thing that's going to be pulling more than an amp. This is the last of our tests. After this, test 9 is actually our end state. The unit should be done checking everything. We didn't have any error codes come across our display. It just walked through each one, 1 through 9. And you can, if you ever need to jump from one test to another test sooner, you can always open the door, hit the start button. That'll jump to the very next test, close the door, and it'll continue on where you just jumped it to. There goes my amperage. I should be on test 9. Display is blank. We're done with our water service test mode. Alright guys, so what does all this mean? I just went through everything. Everything seemed to be testing fine. I was getting proper amp draw across everything. My heater's working. So why would my consumer be calling me out here for washability issues or poor drying performance? We just verified the unit is not the problem. Everything on this unit is working. It's going through each and every test. There's a few things we can discuss with the consumer to try to help them with the issue. Water temperature is a big one. Water temperature needs to be 120 or at least as close to it as possible for this unit to function properly. Rinse aid is a big item. We have to ensure that they are using some form of rinse aid. There is an adjustment in here that it needs a little bit of tweaking, but quite honestly, I find the issue whenever they're having poor washing performance or drying performance that they're not using rinse aid at all. This little sight glass on here is completely empty. The third thing that we got to take into account is how they're loading the dishes. If they are cleaning the dishes before they put them in this dishwasher, the detergent is going to be useless. It's going to be something else that the water has to try to get rid of. They do not need to clean them. The rule of thumb for me whenever I was still in the field, scrape and load. Scrape the dishes off. We don't need the big chunks because you're just going to end up having to fish those out of your filter. Scrape the big chunks off. Leave the oils and stuff on there. Of course, anything like cereal or oatmeal that's stuck to the bowl, there's a good chance it will come off in the dishwasher, but those I would take off before you load them in there just to ensure that you don't have to rewash them again. But all in all, I have no problem telling the customer in this situation the issue is not the dishwasher. Replacing a component on this is not going to do anything for this consumer except give them a false sense that there may be an issue here. We'll talk to you guys next time.